Okay, Xianglin, please start.
Yeah, so the paper I'm going to present today is called Trace Divergence Analysis and Embedding Regulation for Debugging Recurrent Neural Networks. It is published in ICSE 2020. So those 5 authors.
Yeah, I think the second authors will still have the same paper with the session with Dr. Xiaolin, right? So right in the sessions, but I think this guy, I think he is now assistant professor in Roger University. He has a paper. His paper he is presented before the Xiaoyan's paper. I remember that. Okay. Okay, please go on. But basically, they are software engineering researchers. So when reading the papers from the AI communities, you can compare with how their ideas and their writings differ from the software engineering researchers and look on their focus. And I think we should make us very open. So our research work can either submit to the AI conference or SE conference. Anyway, both of them, both AI and SE have top-tier conference, and it also earns your reputations if you have such a publication. Okay.
Yeah, so a little bit background. The recurrent neural networks are very useful in software-related applications because they are designed to deal with textual input and inputs in sequence. And in software engineering area, if you view program as some specific semantics or text, the recurrent neural networks is particularly useful. And it is depend on word embedding that are usually pre-trained by third parties to encode textual input to numerical inputs. So the problem here is in software, for software, we have, if the software have some undesirable behavior, then it is viewed as bugs. So here, if we define model bugs as undesirable behavior as well, such as low test accuracy, there are some, but to debug such models, we need to locate the root cause, for example, problematic embeddings or problematic model structures. Here we have a question, how to debug such bugs or errors. In this paper, we only focus on problematic embeddings. The challenges here is some may use adversarial training method to increase test accuracy, but it lacks of interpretability. That means it works like a black box. We cannot know the root, why the embedding is problematic and why it can increase test accuracy. And there are other recent model debugging techniques. I have reported some before, but often they deal with fixed size input, such as images. So it's not trivial to adopt those techniques and apply them in recurrent neural network because recurrent neural network usually deal with a sequence of inputs.
Oh, by the way, so Xianglin, when preparing these presentations, have you prepared a few questions for the audience to join?
Oh, yeah.
Okay, sure. So I suggest everyone will pay more attention. And usually Xianglin will give very good presentations and his logic is usually very clear. It was for your attention. And also we prepare a few questions for you to join the discussion. Yeah. Okay, please go on.
Yeah, so this paper tried to address this problem to debug problematic embeddings in the context of recurrent neural network. So here is an overview of this paper. First, they view an RNN model as a special program where with specific semantics, and later they adopt the traditional trace analysis in software debugging area to debug these recurrent neural network models. And later, they would identify the internal state vector dimensions responsible for the misclassification. And later, we should have a detailed explanation on what is state vector dimensions. And in the end, after they found those problematic dimensions, they would apply these embedding regulations to harden or fix the model to increase the test accuracy. Yeah, and later we will have more detailed explanation on those 4 steps. And first, to introduce some terminology, you may familiar with recurrent neural network already, but here I just recap your memory a little bit. First, recurrent neural network are a family of neural networks that are designed to tackle the problem with sequence inputs. So like the A in figure 1, we have a unrolled structure of RNN model. It should, the sequence input are fed into the model 1 by 1, and at each time step, the model should leverage the previous hidden state value and the current input, so to update the hidden value. So for the vanilla RNN structure, the cell would take in the input xt and concatenate it with the previous hidden state ht-1 and times a trainable weight wh plus a bias bh and stake a activation function on top to update the hidden values at time step t. And if the recurrent neural network is used for some classification problem, then the prediction is made based on the hidden state, let's say hn. And again, we would apply it with a trainable weight w and plus a bias to give the prediction. This is the simplest structure. And we also have some other more complex cell, for example, Lstm, the long short-term memory cell, and GRU. So those cells would have more complex structure inside. And here for Lstm cell, it takes inputs as xt and the previous hidden state ht-1 and also one cell state ct-1 and output or update a cell state ct and hidden state ht. So that's the basic input output for recurrent neural network.
Okay, so wait a minute. So I will just have a smaller poll. I'm not sure how to do this. I think you can do this in the. And let me add a question. How do I add a, I think I can add a poll, right? So I'm writing comment.
A pool, you mean?
Wait a minute. Let me. I'm sure I can make the. Waiting for a minute. And I would like to create a poll here.
Oh, okay.
Wait a minute. Okay, I created a poll. Can you see that?
No. No. Where?
Okay, so.
Oh, yeah.
Can you see it? I would like to have small poll here. So maybe, yeah, so 2 students have voted. Yeah, so I create an anonymous poll here. Can you see the results? Can you see the result of the poll? Or only I can see the poll? So there are 2 students do not know about RNN, and the 2 of them know RNN little, and the three of you know the RNN. So getting there's 2 students never know RNN. So maybe you can, based on Xianglin's explanations, you can raise any questions if you have any confusion. Since there's 2 of you do not know RNN, and how many of you is not DNN? So maybe I can recap it since it is very easy to understand. So before I'm explaining other complementary explanations, I have a question for Xianglin. So for this research, do they only work for the RNN for classification, or they use because RNN can use for both classification and for generation, right? So they're debugging an RNN. What is the purpose of the RNN? Just for classification or both classification and generation?
Just the classification problem.
Okay, it's just a classification problem. So maybe it is easier for me to explain it just for classification. So basically, the neural network model you can consider as the black box, right? And so given an input, and it will predict an output, right? So this is very easy. And you can consider RNN as a very basic idea as multiple network. So given that, and the RNN is going to address a sequence of input. For example, for image processing task, the input is image, and for the natural language processing, or some other sequence-based input, it will have a sequence. It will be token 1, token 2, and the token n, right? So getting this kind of input is very tricky. So the idea is that we're taking the first input of sequence input, let's call it T1, to input into the DNN, input into a neural network models, and the network model will output a hidden state, just like what Xianglin showed here. Let's call the hidden state H1, and based on H1, the next time it will combine. Let me use another color. The next time it will take the input of T2 and the hidden state again, and to feed into the model again. And after that, the model will generate another hidden state, H2, right? And based on H2, the neural network model will further take T3 and the H2, feed into the model again, and then it will output a hidden state, H3. So getting this process, just as Xianglin showed it, right? So it will have so from the very beginning, it will have an initial vector that's called x0, and we were based on the input. Oh, sorry. So this is supposed to be the token. Here the token is presented by x, and it will derive. Usually it will start with the initial vector that's called something like and whatever it is. Then it will combine the hidden state here and input it here, and all the weights of the network share the same. All the cells share the same networks or share the same network structure and the weights, and it will derive H2, H1 next H, and similarly it will expand the structure, and then finally will got such will make the prediction. And based on this structure, RNN can either used for classification and for yes, there you're right. It's kind of a state for neural network model. And based on the structure, it will be either used for classification or generation. So the classification model is very straightforward. So, and after we go through all the sequence, we will finally generate an output an HN, right? Suppose there are n tokens, we'll finally have an n hidden state. And based on this hidden state, we can connect the hidden state to some other network model and then finally make a prediction. So this structure is called many-to-one RN model because it take the input of many tokens and it will and all those many tokens will share one output prediction. So this is called a many-to-one structures. But it also, so for example, we were using the semantic analysis. The RN can be used for semantic analysis. Giving a sentence. So I like today's conference, or today is very good. So based on this sentence, it will finally output a positive prediction, a positive or being negative. So this is a many-to-one predictions, or it will be used for translation. For example, I know that there are many of us now both Mandarin and both Chinese and English. So the input token can be an English word and the output token can be a Chinese character. It is still possible. So in this time, each hidden state will derive another token or prediction token. In this case, we have many tokens as input and we'll have many tokens as output. And this structure will be called the many-to-many RN architecture, right? So and the many-to-many architecture will be used for some tasks like machine translation. And since Yufan is not here, and Yufan or Yihao's work is that it will take the input of a sequence of code token, and it will output a sequence of natural language description, or vice versa. It will take the input a set of natural language description, and it will derive a piece of code. So based on this type, so the many-to-many architectures can do something more, but of course it will be more difficult. So this is a brief of the RN basics. And I think the later part Xianglin described is that for each of the network, maybe this area, this network, it can be very complicated. So different technique will propose their unique architecture. For example, GRU, right? The GRU we're using a specific architecture, and Lstm will provide another architecture. And each architecture or each component of this architecture is called a cell. So the pink part I draw here is just a Lstm cell, which is showing a lot of details. And I think I leave it to you if you're still interested. I leave it to you to understand why the Lstm cell will be designed like this. Basically, it's going to address problem to remember the tokens appears long ago. So the idea is that they design a lot of gate inside the cell to do this job. Okay, this is my compliment. Is there any questions there? If no, let's keep going on.
Yeah, and I can make a little bit compliment here. So yeah, okay. So no, I mean in this paper they try to address the classification problem using recurrent neural network. That means if you are giving a sentence, they try to predict the sentiment or the emotion for each word.
Yeah, that is also called a sentimental analysis.
And the second terminology is word embedding, because the input should be the word in sentences and the word should first be mapped. Oh, sorry, a little bit type error here. So we try to map the word to numerical values. So the cell or the neural network can deal with those values. There are two kinds of strategy. One is called one-hot vector. That means here, for example, the sentence "I like movies," the I can be encoded into 100, and like can be encoded to 010, and word movie should be encoded into 001. But if you have a large vocabulary, then this strategy is not proper.
I can raise the questions. What if we have a large vocabulary? And what what is the potential of such a one-hot vector encoding? Is there one can answer this question? What if the vocabulary would be? So maybe I make a very simple question. Suppose the vocabulary size is 100K vocabulary, and what is the size of the one-hot vector? So anyone can answer this question. So this was going to be very simple. Xianglin, maybe you can help me point to one.
I don't know. Darren.
Hello, Darren.
Yeah, can
Suppose we have vocabulary size of 100K. We have repository of 100K vocabulary, or all vocabulary has 100 words. And what is the vector size after we apply one-hot vector?
100K?
Yes, you're right. Okay. So just a small question here.
Yeah.
Good work.
Yeah, and the second strategy is called distributed representation. It means we represent words to leverage all the dimension of word embedding with continuous values. Usually we do this by training a network on large corpus. Here just again the same example, I could be represent or encoded as 0.9, 0.3. And
wait, Xianglin, so there's a question here. Maybe I think you can address. So Yuchen is asking, one-hot vector doesn't make any distinguish for repeated words. So if, for example, the word bank can either refer to the side of a river or a commercial company. So the question is, one-hot vector will not distinguish this, right?
Actually, my question is more like, let's say that my string is like all the same words, right? So each word will have its own, it will have a different vector depending on the position, right? So
can you raise an example? So for example, I like movies. So what does your repeated words mean?
Right, let's say that the word is like I like movies. So there are two likes. So the second like will have 0, 1, 0, 0, and then the first like
they should be the same.
They should be the same.
One-hot vector will make they're the same.
Yeah.
Because they corresponding to the same word in the vocabulary, and each vocabulary will have a unique encoding.
Oh, okay. So it's the vocab, not the input string, right? Okay.
Yeah, and then that is a very great question. For example, I don't have the examples in my mind. Sometimes maybe the bank manager work alongside a river bank. Maybe there's such a sentence. So the first bank and the last bank actually will have very different semantics. But based on the one-hot vectors, or even based on the word embedding technique, those banks will be represented by the same embedding vectors. And so there's a lot of technique called BERT, or the graph BERT, or Robota. And those kind of the model is going to address such a problem. So based on where the word bank appear, they will assign a different embedding vectors for the specific word. Okay, I think I have made myself clear.
Yeah.
Okay, Xianglin, please go on.
And so the distributed representation is to use continuous values to for all the dimensions. And here, what I want to say is embedding is very important because the embedding should be fed to some other downstream model to used in other tasks. But if the embedding is not appropriate, then there will be some issues. For example, here, if we try to compare the similarity between words based on their embeddings, here we have some examples, like the first column, error. We calculate the similarity between the word error and some other word, and the nearest neighbor is correct based on their embedding, and then mistake difference by their rank. And from our human interpret, the correct should not be the nearest neighbor, and they report that after their regulated embedding, the nearest neighbor of word error becomes mistake, and the correct become the last one. So here I just wanted to say the word embedding is very important. Yeah, and then
maybe I have a complementary here. So we all know that one our embedding factor is too brute force to be useful. And for anyway, if we want to feed a token into a neural network model, we have to vectorize it into a numerical number for the model to pass. So how to represent the meanings of each word, just like Xianglin mentioned, it is very important. And the ultimate goal for word embedding is going to make similar word, the representation of similar word similar. For example, the vector of queen minus king should be similar to, or should have a similar distance of the girl minus boy. And also, if these two words are very similar, for example, quick and fast, should be presented with the similar vectors. And the example provided by Xianglin here is that for the first two columns, it is showing that the word error, have a very close neighbor, correct, which is counterintuitive. So in this case, in this research work, they propose embedding regularization technique, but I'm not sure it is manual or it is automated or semi-automated approach. We are still not clear now, but after apply this technique, it can correct or re-ranking the representations and make the embedding of correct far away from the embedding of errors.
Yeah. Later, we would adopt some software engineering debugging technique to debug model, because when you think about it, you can view model as a very special kind of program. And here we define model bugs as the models have undesirable behaviors, and we define the model debugging as a procedure to understand the model internals and find or locate the root cause of those misclassification behavior. And later we should conduct countermeasures to fix the root cause. But how to interpret these concepts, we have a motivating example to help you better understand how to adopt this concept into model debugging. So here we have a very simple counting program. And the embedding function in the line 4 means mapping a string to its closest discrete integer. For example, the string 1.1 should be mapped to integer 1, and 1.8 string should be mapped to integer 2. So here I have two simple questions. Because in the count function, we have a loop structure inside, and for each iteration, we should update one variable output. Anyone can tell what's the correct output value in each iteration. So
It is good questions.
Yeah.
Anyone would like to? Maybe we can give 1 minute for people to think, and
Oh.
then later we can ask one.
oh, okay.
Audience. Yeah. I assume all of you are very familiar with Python code, right? Okay, I think there's enough time for think. Xianglin, you can point anyone to have a try.
Yeah, so maybe, I don't know, Yuchen. Hello, Yuchen, can you answer this question?
Okay, so each iteration, I think the first one, okay, so 1.1 becomes 1, and then
Yeah.
output will increment, and then for the second one it becomes 0, and then it doesn't, and then the third one becomes 1, so output increment again, so now output is 2, and then 1.8 becomes 2, and then the output does not increment, so the final count is 2.
Yeah.
Right, and
Yeah.
seems like the program is just looking for values that round to 1 in the data.
Yeah, so yeah, that's correct. You
That's
also
great
asked
answer.
the second
Yeah.
question. Yeah, correct. So basically this counting program tries to find how many number inside this list that are between 1 and 2, right? So here, if we view the output value as a if we record the output value and it become a list, here we got 1, 1, 2, 1, 1, 2, 2. Oh yeah, 1, 1, 2, 2. Yeah, correct. It becomes a trace. But consider if when we execute this program and got the trace 1, 1, 2, 3, for example, then there is a difference between the correct trace and the trace we got after we execute this program. Then after this, we can compare at which step that this output value different from the correct one. And if in this case, we know that at the fourth input, this trace becomes different, then this 1.8 could be our like root cause on why this program behaves different, right?
So my question is that based on this technique, you're allowed to trace execution there. But we need to have a reference. How do you get a reference in normal case? In practice, how do you go? Because based on the correct version and buggy versions, definitely we can align trace. And where can we get that correct version?
Yeah, that's a very good question. So in reality, we don't get the correct trace, but later we will talk about how to fix this issue. But here the point is for you to understand the trace and how to use the trace to locate where the problematic input is. Yeah, so here the counting program and the RNN program actually shares a lot of similarities, because for the RM program, it also have this loop structure. And when we input some, we have a sequence input, and then the hidden value would get updated in each iteration. And if we can record those hidden values and form a trace and compare it to the correct one, then maybe we can locate where the problematic input is. So here, for example, in the trace analysis, on the right, we have the correct trace, or the oracle trace, and the buggy trace. And the x-axis represent the input sequence, and y-axis represent the prediction output. Like if the prediction is larger than 0, then that means this word is positive. And if it's -1, then the word is neutral. And if the value is smaller, then it means the word is negative. And here we know that at the input match, the trace have a divergence. So this is where we find the problematic input embedding. And later we can further inspect the differences at the divergence step. This is how we do it. The second sentence also, Joda time makes calculation with time much simpler is the input, the sequence input in the previous slides. And we know that the word much is problematic. And they think the root cause is the RN means the model we trained that gives the wrong prediction. And why is that? This is because in the training pool, they have the first sentence, create number of buttons that you want with different button ID. The word different in this training sentence have the most similar embedding with the word much. And because of that, the prediction of different and much is different. So the RN makes the wrong prediction. And below we have an oracle. Suppose that oracle is trained on validation set, or anyway, and the oracle knows that another sentence has a word better that have the most similar embedding to the word much. And that's why the oracle would say the much and better should have the same prediction. And by doing this, they found out the dimension where we circled by red and blue is the one that is the most sensitive or more vulnerable, that makes the RN to make the wrong prediction. So that this dimension is picked up or is recorded as the root cause on why the model makes the wrong prediction.
Actually, based on description, I'm a little bit lost based on your description. So I have a few questions here. So still based on your, you have 3 sentences, right? The first sentence is create a neighbor button, etc. And the second sentence also, and the third sentence is databases. And which one is the oracle? The second sentence? Which one is the
Sorry,
oracle?
Mike.
Oh, I'm showing that you have 3 sentences.
Mm.
And which sentence is the oracle?
The last sentence is the oracle.
And why it is the oracle?
It's from the validation set.
But the RN is trained, right? So the goal here is going to see whether the vector has been where embedded, right? So we are actually looking to the embedding, and the embedding and then we feed the embeddings into, basically embedding is just a deep learning model, right? The embedding can be a deep learning model, but it is a third
But
party.
the embedding is a vector.
Okay, so they do not apply dynamic embedding, so they just hard code the embedding. Let me make my point more clear. So when we talk about embeddings, there's maybe two ways. The first is that because we do not, maybe focus the model may or may not train an embedding by itself, right? So they have to, it can either borrow an embedding technique. Maybe this embedding is a DNA network, and then it take the input of the one-hot vector, let's say one-hot vector, and it output embedding vector, let's call it B. Okay, right? Then we feed these embeddings into an RN. Okay, so that will be very clear, right? And what I'm talking about, I assume it would be the output of RN. But finally, the RN will have an output, right? And this output including the hidden state, because the RN still will have the hidden state, right? So what I'm talking about is the hidden state, or those A and B. What I'm talking about, because when you are showing these slides, there are so many informations, and you just keep saying. So sometimes, and also I assume that you sometimes jump from sentence 1 back to sentence 2, and jump from sentence 3 back to sentence 1. So when you have that descriptions, I kind of lost based on description. So can you pinpoint based on my graph and tell us? So we have 3 sentences, and each tokens in the sentence will be embedded to embedded vector, and what is A and B? What A and B is?
Okay. So sorry for not explaining it clearly. So first, I forgot to mention, we define the model state as the concatenation of input xt and the previous hidden cell, the previous cell state ct minus 1 and previous hidden state ht minus 1 as a model state, and followed by an output. It's like, suppose this is the model state and this is the output for one single word.
Maybe I'm writing it in a more clearly. So for each cell of it can be either an architecture, it can either be an Lstm or a GRU, whatever it is. It will take so this is xt, right? Yeah. You can write xt, ct, and then what about ht minus 1?
And
right?
ht minus 1, and for each word
ht minus 1 is its output, right? It's supposed to
it also is output, and we again feed the hidden state to the next. So for each word we should have this model state, and here the A, B, and C, D represent each one represent one model state.
But it is supposed to be what? So what is xt? So this vector. So maybe I need to.
Xt should be a word embedding.
Yeah, I understand. So is this a word embedding?
This is a model state.
But this is a one, right? And what this one and 2 is about?
Sorry. Which one? So
you are saying that A and B is a model state. A is model state, B is model state. And the model state should conform to this form, right?
Yeah.
And if they conform to this form, how, giving the example of A1 here, which part corresponds to xt, and which part corresponds to ct minus 1 and ht minus 1?
Yeah. Remember that I can write model state as this form. Q should be the output and P is the suppose is the
Input. Okay.
yeah, it's this one. And then you see there is they are the same form, and 1 and 2 should be the output. And this part, I'm not sure. Suppose XT have 50 dimension, CT have 50 dimension. I just making it up, and HT have 50 dimension. And this list should have 150 dimension. Here they just show 3 values. This is an example, right? And
Okay.
and the second sentence, remember in the previous, in the previous slides, how can I go to the previous?
We can stop playing and restart it.
In the previous slides, the input sequence is also Joda time mix calculation with time much simpler. Can you see it? And we the trace divergence happened when we have input much, right?
Yeah.
And then this is the second sentence. And
Also, they are comparing 2 models.
yeah,
Two different
yeah.
R models. Okay,
Yeah,
so that is the point. We are
Yeah.
comparing 2 R. Suppose we already have 2 models. One is the correct model and one is the buggy model.
Yeah.
And given the same input, there now you are comparing A is the output of
One sentence 1, and B is the output of sentence 2.
sentence 2. Okay.
B is the output state model state by
So A and B are output of the buggy R model. Am I correct?
Yeah,
Also,
yeah.
this is a buggy R model.
Yeah,
I'm
and the
reading-
oracle should be the
and,
correct.
And this one supposed to be the oracle model.
Yeah.
Okay, so that is a point. Okay.
And why is RN make this wrong prediction? Is because the first sentence is from the training data set, and the word different, the model state of the word different is the most similar one in the training, like, for example, in the training pool, that is similar to much, right? That's why the RN will make the prediction of much the same as different.
Okay.
And then for the oracle, because it knows that the third sentence is from, let's say, validation state, and oracle knows it, and the word better has the most similar model state with the word much. So oracle would predict the same label for the word better and much. That's why it gives the correct prediction.
So I think I kind of understand the details after Xianglin's explanation. Is there anyone a confusion on this part? So this is a modeling example explaining why the model, why the 2 models will have different behaviors. And right. So anyone have a confusion here, or maybe I'm doing the explanation. But since we are kind of a little short time, so we need to proceed fast. But anyway, it is very, very important to make the motivating example very clear. So here, so anyway, what the deep neural network model do is to learn an internal representation. That's why we need embedding. For example, Xianglin has shown that in the previous example, the word much is the debugging model have a different presentation of much than the oracle model, right? So in this case, he wants to understand why such a phenomena happens. So for bugging model, it is select a sentence. So first it know that the word much in the bugging model, it is represented by a numeric, a number, maybe minus or negative 0.0063. Then it search from the database and find another sentence with a token different. And the token different is represented by the buggy RM model into a number which is very similar to much. It means that from the perspective of the buggy RM model, much is equivalent to different. In contrast, it applied the same technique on the Oracle model. So from the perspective of the Oracle model, the word much is equivalent to better, right?
Yeah.
So in this case, it can infer that, but of course, different and better are very different, have different meaning, right? So by this means, it can explain that why the bugging model and RM model will have such a problem. So it is basically it's actually taking a reference from the database, from the perspective of a certain buggy or Oracle model, and make a comparison. So next maybe, so here it is quite clear to me now. And what I'm curious about now is that how do we leverage this rationale to facilitate the debugging or automate the debugging work?
So after we have find those two different words as reasons, we will further try to find which dimension in the model state that will cause this error to happen. So we compare the different dimension and found out that, for example, the dimension circled by red and blue should is the root cause, right? And then they claim that this dimension is more sensitive or vulnerable, and use a very fancy sentence saying that the essence of their technique is to harden the word embeddings with respect to those dimensions. But from my understanding, it just means they do an adversarial attack with respect to those vulnerable dimensions and get some adversarial samples and retrain the model to increase the test accuracy. So that's the high level understanding.
So how do they apply that adversarial?
Yeah,
so they're going to
wait.
change, okay.
Yeah. So, yeah, I also found out how to get the oracle in reality is not possible, right? And then they designed the trace generation algorithm to address this problem. So first, they leverage the validation set. For example, here the validation set, and then feed those sentences into the model, let's say the bugging model or the model we try to debug. And then for each word, we should have a model state, right? Remember that the model state. For each word, we have this model state. And because it's validation set, so we know the correct Q. And if this model states the Q
The Q
output
is the prediction or something.
predict the sentiment prediction. It is whether it's positive or negative or neutral. The one output. And we compare the prediction to the correct label. If they are the same, then we add this model state to the oracle pool. And if they are not the same, then we add this model state to the buggy pool. So in the end, we should have a oracle traces and buggy traces two pool, right?
Okay.
And after this, in the next step, they construct a buggy machine and oracle machine. That means they just use a linear regression to fit two database. Because now each sample is the state. PT, remember PT is the concatenation of xt, ct minus.
By the way, so but each sample can correspond to multiple states. right?
Each
The sample you mean is a token.
no.
So what do you mean by what's the definition of a sample? A sample is a
Oh,
sample.
now it's just one model state, PT and QT. This is one
sample.
model. Yeah, one sample, yeah. And the PT is a high dimensional vector, XT and
I understand.
Yeah. And then for the buggy machine or the buggy database, they have a lot of model state, and they use a linear regression to fit.
So they want to learn what kind of model state is more buggy or more correct, more likely to be correct.
Or so here the weight WR represents
A coefficient.
the importance of individual dimensions of the state vector, right? This interpretation.
Okay.
And for the buggy machine, then we have two models or two linear regression models. One is for the buggy database, and the other one is for the Oracle database. And then later they identify sensitive dimension. How to do this is we take the weight of Oracle machine and take the weight WB for the buggy machine and do and minus do WO minus WB. And then
So wait, I need to clarify. So since we are learning linear regressions, so a linear regression has to have both positive and negative samples, right? So it means that
regression is to learn to fit. Is
but the Q is either 1 or the QT is either 0 or 1, right? It is a 2-dimension.
QT is not binary.
Why is not binary? So okay, so if it's not binary, maybe tertiary, or it has 4 value.
Right.
So
for the linear regression.
No. What I want to ask is, so you have a data set of Oracle, you have a data set of debugging, right? So you train a regression for each of them, or train them all together?
We train one for the buggy model or buggy dataset and train one for the Oracle machine dataset, Oracle dataset.
Okay.
So here the weights, each dimension of the weight show the importance of each dimension of the corresponding dimension in the state vector, right? Because the weight should have the same dimension with the PT.
But the point is that what I want to ask is that yes, we can get WO and WB, but that is for different samples, right?
No, it's like the linear regression is like for like if we have a lot of samples and we feed them to learn this W and B, the weight.
Yes.
And they try to do the simplest prediction based on PT, how to get the outcome QT.
Yes, I got it. But I'm just wondering why they want to subtract the vector
to
WO and WB.
get the sensitive dimension. Because the difference between them should be why, because if we have the same PT, then the buggy machine would have the different prediction with the oracle, right?
But how could they get the same PT? Because you can think about how they construct the bugging machine and oracle machine. So they go through the validation set, right? And go through the validation set. Yeah. So giving a sentence, if it predicts the QT correctly, QT means sentimental analysis result correctly, and it will put all the model state of each tokens into the oracle machine. And if a sample or if a sentence is not predicted correctly, it will use to construct the buggy dataset. And the oracle dataset construct the oracle machine, and the buggy dataset construct the buggy machine. Now it comes to a question, the common problem is that giving a sentence, it will be either predicted to be predicted correctly, or incorrectly, but not both. So in this case, how they conduct the sensitivity? So one sentence will be only appeared in either buggy or oracle, and how could it be apply differential analysis on different samples or on different sentences or on different model state? Have I made myself understood?
I don't quite get you. I don't get it.
The point is that they have validation set, right? They have validation set. They have a lot of sentences, S1, S2, and Sn, right? And each sentence will have a lot of tokens that understand the T11 and T1 and exceptions. They're similar. And for each token, it will derive a model state, PT and a QT. Right? So this is the point. Okay. But the point is that suppose S1, S2 has been correctly predicted. So I'm using maybe S3 and S4 has been incorrect predicted. Right? So in this case, it means that for all the model state will be used to construct it as the oracle, right?
No,
all the model state will be constructed the buggy. It's correct or not?
No, they don't. For one sentence, I think you think that for one sentence they only have one prediction, but here is if we have a sentence, for example, have 3 words, we have one.
Okay, whatever. Okay.
One.
Okay, so I understand. So maybe for this sentence, some of its tokens have been wrongly predicted, so it will be put into the bugging machine. So that is fine. But my point is that the model state. Okay, so the idea is that getting the so the idea so I think one of the now I got a point, but I think you're giving these slides, you keep explaining how, and do not somehow miss the point of rationale and why. So this slide, the purpose of this slide is going to find which dimension in the model state is more sensitive or more buggy, right? So that is ultimately goal. So based on this goal, you're going to learn. He is going to using something like coefficient or some importance analysis of each dimension for each dimension on the model state to see which dimension is more important for the buggy prediction and which dimension is more important for the or which dimensions is more sensitive or contribute more to the buggy prediction, and which dimension is contribute more to the correct prediction, right? And by this means they can calculate the WO and the WB. Then the subtract. So if
Yeah.
I still feel it a little bit weird, they're using abstract vector. Suppose one dimension contribute a lot to both the buggy prediction and the correct predictions. Then this dimension will be the value, the differential value of say such a dimension will be 0, right?
Mm.
And they will consider this dimension is not that important.
Mm. Yeah.
Why? So I think as long as one dimension contribute a lot to the buggy prediction, even if it contribute, for example, there is a very good student, right? It brings a lot of honor to the organization, and
Mm.
also it creates a lot of disasters to the organizations.
Mm.
And why do we ignore these students? Right? The metaphor of students corresponding to the dimension.
Because when you are given a PT, let's say, oh, like this example showing on the slides, for example, we have 50-dimensional embedding, 64-dimensional cell state, and hidden state 64-dimension. And based on this PT, the buggy machine and Oracle machine would give the different prediction. And if we do a subtraction of WO and WB, we can see
Yeah.
how
Say for example, one of the hidden state have a lot of contribution to make the correct prediction, and also have a lot of contribution to make the buggy predictions, right?
then that means this dimension is sensitive.
And but based on your formula here, so here it will suppose it is very large number after the subtraction, it will be eliminated, or the value, this value will be eliminated, right? This is a subvector.
Oh, I see your point. But if they are both
Very
large,
large, yeah.
that but why the buggy machine and Oracle machine made different prediction?
You don't know.
Mm.
You don't know, but that can be the case. Okay, maybe we can skip this point. But anyway, there's a way. They're inventing a way to calculate the importance of each dimension in the model state of each token, right? And also maybe you can explain a bit about the abstract what these multiple vector
Oh,
means.
and P is the sum of those buggy or those buggy data. They just sum all the D or sum all the all the samples in the buggy data set and do a multiplication of WD and D, because now WD represents the important dimension that makes the model to make the wrong prediction, and then multiply.
No, if we're using subvectors, WD also means including the dimensions where it contributes to no buggy prediction, but it contributes a lot to the correct prediction. It is still possible, right?
You mean those zero dimensions?
Yes, yeah.
But here they just assume W when we do a subtraction, then we left out those important dimensions.
Okay, so it just leaves the dimensions which
and then you multiply with those buggy samples to and after that, if the dimension have a very large value or negative value, that means it influences a lot. No, we don't care whether it's positive or negative, as long as it contributes a lot, then we record this dimension. That's why we have an ABS function.
Okay.
Yeah, and on the right is an example. So the red means the original model, the value of D in each dimension for the original model. There are some dimensions that contributes a lot, and they show that after the regulation, which is the blue line, it become smaller. It's just an visualization.
So it seems that
Mm.
I think it's very clear until now.
Mm.
The only debatable part is that how they calculate the SELab and multiple multiplication.
Mhm.
So, but anyway, so that is not that important for our discussion. Let's keep going.
And later, it's just they apply a adversarial attack with respect to those vulnerable dimension. So first, they would set a threshold, and if the value in those dimensions is above those threshold, then they see those dimensions as vulnerable or sensitive. And later, they design a loss. From high level idea is when they apply some or add some perturbations to the cell state, hidden state, or input, then the prediction outcome should not be different from the original model. Right.
Okay.
Yeah, and
So they just apply the random. But the point is that how we should not apply the perturbations on the internal state in a straight directly, right? So what we can control, just like we can just apply the change on the input, right?
No, they actually add a lambda perturbation to the cell state and hidden state, and add epsilon to the input. Can you see the visualization?
I fully understand your point, but what I'm saying that C t minus I, t minus 1, and h t minus 1 fully depend on the x, the value of x, right? So it means that we cannot directly apply lambda or add lambda on C and H. By right, we can only apply the change on the X.
But remember that our model state, we have three parts. One is
I know we have three, but this
so
three
they
part. But the point is that the model state, those dimensions in the model state is not independent. They are actually dependent on each other, right? So why they can apply the perturbations on the internal state? But right, for example, if we train we apply the adversarial training on the convolution layers, is that appropriate to apply the perturbations on internal vector, internal weights in the model, inside the model?
I know,
It
Bayesian
seems to be weird, right?
Like Bayesian neural networks, they add this random property, right?
But anyways, their point is that even if the weights has perturbated a bit, they still want to the model prediction is stable. Is stable.
Yeah, that's the idea. So
And also, I have another questions to ask is that for adversarial attacks on NLP applications, for example, it is very straightforward to add a random perturbation on an image, right? But given a sentence, for example, saying that I love the country or the day is a great day, and how do we add a perturbation on the language on such a sentence per se?
The XT is the word embedding. It's already numerical values.
I understand in these applications, but sometimes the word embedding components is trained altogether with a downstream task. You get what I mean? So by this means, the perturbation cannot be added on the output of the embedding network. It should be added on the natural language input per se,
Oh, but
right?
yeah,
So this is so I think one of the, of course, if this technique have a good result, that is okay. But from the theoretical point of view, C and H totally depends on X. And that means a lot of the input added into the models seems to be a fake input. They will not be realistic in the real world, or in your words, just like a manifold. So those inputs, randomly constructed inputs, will not be it does not exist in the real world manifold.
but the lambda and epsilon should be a very small value.
Okay, so maybe we can skip this. But anyway, say when they train the model, they train the model.
This loss is used for training the lambda and epsilon. So they try to find the lambda and epsilon when we add those perturbations to the hidden state or input X.
I didn't get it. I didn't get your point either. Lambda and epsilon should be random value, right?
Yeah, they are random values, but they use this loss to train to find the best perturbation. Because now
why they need to find the best perturbation? I don't get this point. So lambda. So for example, you are doing the adversary training, right? And the adversary training is going to using some basically some data augmentation technique. And for the data augmentation technique, and why you need to find the best way to augment the inputs, just like an image, a human face, and a randomly generated added noise on the images.
Yeah, but how do you find the noise?
We randomly add noise.
For example, like
through Gaussian perturbation.
But here is not random noise. They try to find.
And the lambda and epsilon is supposed to be a small number. So in this case, we just need to add some small number on the model state. That's all. And why there is an optimization problem here?
For example, in FGSM, the noise is calculated by the gradient, and also the CW2 attack is to find the minimum noise to change the label. Right here is the same. They try to find lambda and epsilon to make sure the outcomes still the same.
If that is why they need to pick up the dimension.
So they only add noise in those dimensions.
But isn't that the same way we do not have any dimension selections, and let the adversary optimization on those dimensions itself?
Because remember in the beginning they said the adversarial training is like a black box. They try to find the root cause on why the model gives the wrong prediction. So when they try to pick up the dimension, it's the process of finding the root cause. And after they find those dimensions.
But I'm not sure whether the adversary sample, because the adversary samples generate the adversary training will generate the adversary samples through gradients. And the gradients can still be regarded as a another way of root cause location, right? So we just need to find the minimum perturbation.
In this paper, they only focus on the problematic embedding. They do not care about model structure. So here we just assume the model structure is fine. And because the recurrent neural network have this iteration of taking input, so if you just add a random noise lambda, then this noise might have this effect to so the point here is to find a lambda that the L2 loss is try to restrict the prediction at each iteration to be the same.
Wait, you are doing adversary training. It means that you must conduct adversary attack.
Yeah, so this process is try to generate some adversarial samples.
Yeah, so what I mean is that so do they do the experiment if we do not identify those sensitive dimensions? And we just purely apply the adversary attacks, and can we find the relevant dimensions?
Yeah, this is also what I ask, because in their experiment, in this part, they said they regulate all dimensions, and I feel that they didn't compare. For example, they select a subset of dimension and with regulate all dimensions.
And I highly doubt that without select, for example, they spend so many effort to train the linear regression and to calculate the dimension which is more sensitive. But if we just apply adversary attack, and we may also find this kind of dimension, right?
Yeah, so that's also what I ask when I read the experiment part.
See, I think I think they propose some interesting story. They write a very interesting story.
But in the end, it's just adversarial.
Yeah, but in essence, there's questionable novelty and worrisome evaluation from my perspective. But anyway, there's publication, they publish, whatever. So let's keep going on. But I still have, so when we have for example, when we read the paper together, I think Xianglin present a very, very good example that how we discuss the work. So when we discuss the work, first Xianglin almost digest every details, and somehow he defended for the authors. Somehow we share the text for the work. But anyway, by going through the discussions, we not just read the paper per se. We would like to get an insight. Sometimes, and through this process, we will become more picky, especially for PhD students, and you will be the reviewer one day. And at that times, when you read a new papers, you are not look forward, you are not look upward to a paper. Sometimes we also need to look down upon the paper to see what is an interesting part and what is the weird part, or which part is unconvincing. So it's good for us to have these critical thoughts. It will be good for us for the future academic career. Yeah. Okay, keep going on.
Yeah. So based on the loss they design, so the cross entropy loss is for make the same prediction, and the L2 norm is when they make the same prediction, the score should still be the same. These are two restrictions. And after they get those adversarial samples, they just retrain the recurrent neural network. So yeah, that's all. And when they do the experiment, they use 5 data sets. They are all review data sets. One is Stack Overflow discussion, mobile app reviews, and some issue comments. I didn't check the details. And the model they use vanilla, RNN, Lstm, and GIU. And for the word embedding, so in their experiment, the generation of embedding and downstream tasks are separate. So that's why maybe they can regulate the embedding, and they choose 3 embedding generation method. And for the baseline, they use some state-of-the-art iron hardening technique, some penalizing weights,
And
and
choosing the weakest baselines. And
yeah.
so the paper becomes more publishable. Okay, let's keep going on.
And then for the first part is to evaluate the time and space allocation for doing the trace divergence analysis. Basically,
So why it still calls the trace divergence? It is actually not a trace divergence, right? So you just pick the
dimension.
Yeah, they just pick about the training a buggy machine and or pick up consider one sample as a model state. They just pick a lot of the model state and train a buggy
Oh,
and an oracle machine, and that's all. There's actually no trace divergence here, right? Based on approach.
yes. Yeah.
Right, there's no trace divergence. Also, that story, I think that story you mentioned at the very beginning is very beautiful. So
Yeah,
that
and
means,
later it vanished.
yeah, and later it seems that, and how can they connect those? Now maybe we can think through this direction, and this direction, the story, I think it is really inspiring. But for the approach design, it is troublesome. I think we have the same problem when Wang Chao reported one of their FSE 18 deep learning model debugging work. We still have a lot of the questions based on their technical design. Okay, let's keep going on.
And yeah, the conclusion is they are reasonable. And then to evaluate the linear regression model of buggy machine and oracle machine, they calculate the correlation between P and Q. Anyway, the value is between range 0 and 1, and if it is close to 1, then that means
It fit well, right?
yeah, it fell well, and basically all the value is about 0.8, and they said their model is good.
Okay. Keep going on.
And then for fixing model bugs, that means if they apply their method, the test accurate, the value, each value in the table is the test accuracy, and they compare 3 word embedding, 5 data set, and 3 model structure, and the original means the original model, and RS means the baseline, and trader is their method. And yeah, they said they regulate all the dimensions. So here I think they should compare if they only add perturbations on the dimension they found, and all the dimension, if they are nearly the same, then I think maybe
Okay.
their method, yeah.
Let's keep going on.
Yeah.
Let's keep
And
things-
later they show a case study. Basically is there are 1, 2, 3, 4 examples here, and for each example, the first line is the original model, and the second line is the result output when they regulate the embedding. And the color represent the sentiment. If it's blue, then I think it's positive, and if it's red, then it's negative. And the brightness represent confidence. And
What is I think the green means neutral, right?
oh yeah.
Green,
Oh sorry, blue means positive, green neutral, and red is negative. And yeah, for the first sentence, yeah, this case study just shows their result is more reasonable because worked represent positive, and in the original model, it's neutral. And yeah, for each sentence, their Mm.
Okay, got it.
Yeah,
So,
yeah.
okay.
So but
Mm.
that's all for this paper.
Okay, so I think Xianglin make a very good presentations, and so in the future, we encourage all the follow-up students can lead us on, like can lead a discussion like this. Sometimes one paper will be very inspiring, and sometimes one paper was to be criticized. But anyway, we go through those kind of discussions for everyone to understand what's really going on the research point of view, to analyzing deep learnings, securities, and some software engineering technique. Okay, thanks, Xianglin. So Yuchen, will you please share your slide?
Yeah, okay. Okay. Yep. So let's go through the previous sharing first. So recall that this is about inflection point hypothesis. It's about a tool called Chirux that compares the trace of working, not say a working but compares a trace and then a buggy trace, and then it will try to find the point of divergence. Right. So I think one thing that I need to clarify is the output. So after reading with the end in mind, right, I realized that the input, right, the input is actually unit test that has nothing to do with the failure. So what the whole tool is doing is that it's trying to find unit tests that operate very closely to how the bug is produced, and then it creates a unit test to find this bug. So the final output is that you have a unit test that can be added into the code base, and then it will prevent further occurrences of such a bug. Yeah.
Wait, so your point is that you're going to create a unit test to reproduce the bug.
Yes.
So you know that if we want to construct a unit test, a unit test consists of two components, two parts. The first part is input. We need to prepare the input of a program, right? And the second is that the oracle. Oracle means that the expected output given the input. Hello?
Yeah.
So a test case is just used to compare whether the provided expected output is the same is the same with the generated output.
Sorry, the
Let me say
is
again.
compared.
Let me say it again. So a unit test consists of two parts. The first is the input. The second is the expected output. A unit test passed if the generated output from the input is the same with the expected output. Otherwise, the unit test fails, right?
Yes.
So my question is that what is and if it's going to automatically generate the unit test, and how they going to address the oracle or the expected output?
Okay. I think what they are doing is basically they somehow can construct a sequence that passes if the sequence is in a specific sequence, and then if some of the nodes are interleaved and then they switch places, then it will fail. So it will construct this series of operations to produce said sequence. So in terms of the output, I think they just like take the existing unit tests and then they just copy some parts. And so the output would be similar to the existing unit test.
Sorry, I somehow missed your point. So how do they infer whether a test case? Can you repeat how they infer whether a unit test should be fail or pass?
Okay, I think maybe when we go into the algorithm, it'll be a bit
Okay.
clearer.
Okay, so maybe you can re-clarify what this paper is about. For example, for Xianglin's work is based to debug or retrain an R model. And for your work, for your presented work, and what is ultimate goal and what is problem, can you re-clarify this this work? And then we quickly move because we once talk about the idea before, but it's good for us to recap the problem definition.
Right. So to recap, the tool is trying to. Okay, so the setup is that you have a large code base with a lot of unit tests that has a wide coverage. Okay, and then somebody makes a bug report. So the bug report comes with the steps reproducing the failure. And so what happens is that the tool takes this sequence that results in a failure, and then it compares with unit tests that pass, and then it will try to figure out, what is a sequence that passes that have the longest common prefix with the failure execution, and thereby identify the root cause. And
Okay.
yeah,
So here, my question is that does sigma F and the omega F, focusing the failure execution and non-failure execution, share the same input? So these are questions I raised last week. Can you address this question now?
Can you raise the issue again?
Whether the failure execution and the non-failure execution share the
same input.
Yeah.
Yeah. So yes, it does. So in this case, right, the output is not only this unit test that has the same input and output, but also it gives you the instruction sequence. So part of the output is that they will force the operations in a certain way to make it pass. So that's how they get this sigma p. Yeah. Okay, so let's go through the algorithm again. Right, so remember that first we have to do some slicing. We do some slicing from the buggy side, and then we compare it against all the unit tests that are close to the buggy execution. Right. Okay.
By the way, my question is, does all the unit tests share the same input?
Does all the unit tests share the same input?
Do all the test case share the same input?
No. Yeah, in this case, no. Okay, so for the part about the slicing, so suppose that we have this execution, right? And this is the buggy execution. So what the algorithm will do is first do a static slicing. And recall that the static slicing basically looks at the control and data dependencies between all the lines, and then it marks the location. So for example, 28 is the symptom, right? So the where the error starts. And then we see that, okay, it has to run line 27 in order to throw this error. So from line 27, we see that number needed is something that the data is dependent on, and then it will also include lines like 24 and 22 that changes the number needed. So all these locations will be included in the slice. So we have a subset of the entire trace, and then from this trace we do another dynamic slicing. So a dynamic slicing would be something like, let's say that a line, whether it runs or not, does not affect in the failure. So in this case, right, for a dynamic slice of this method, you can see that number needed is not decremented, and therefore when it is more than 0, it will throw this exception. So this line is actually not run during the failure. So even though there is a data dependency in the dynamic slice, it is excluded. Okay, so dynamic slice, we have even smaller subset, and then after we do the dynamic slice, we group it by threads. So orange is one thread and blue is one thread, and then from there we add the thread that gives us the symptom into this thread queue, and from there we start to do a comparison. So remember that we use all the unit tests, and then so we will
So here, each node here is a step instead of a statement, right?
a step instead of a statement.
So for example, I'm running something here, 4, suppose it's 4, and x equals x plus 1. Okay, so this is a statement, right? This is a statement, okay? So through dynamic slicing, it will keep slicing itself, right? So suppose this for loop has been executed for 100 iteration, and this statement will be appeared 100 times or 100 times in your trace, right?
Yes. They do something else also. So we'll go into that under the compare part, but they will remove some of the statements, or steps. Okay, so I'll use the terminology steps then. So okay, they will compare between the unit test and the slice or the dynamic slice, right? So they will find the common prefix. Now, after we find the common prefix, they also do another step where they will try to modify the unit test such that they will run, they will change the execution such that now there's a greater similarity between the buggy execution and the unit test execution. So how that is done is from some, they defer to some other algorithm. But essentially they will look at this, there's a split in the execution, right? At some if junction. It's usually a control flow junction. So from there, they will actually flip the Boolean and then they will try to run it again.
So my question here is that they are going to flip the execution of the buggy version, right? The buggy test case.
No, the passing one.
The passing one. So okay, they flip the execution or force execution. They apply force execution technique on the passing technique. But after the force execution, or for example, if the code, the original code should go through the true branch, and after it's flipped, it will go to the false branch. And if they apply this technique, the result will be changed, right? The result will be changed.
I think, but that goes into the details of some event chaining algorithm that they didn't talk about. But I think what they are looking for is that in the end the outcome actually doesn't change. So they're trying to
Outcome, for example,
sorry.
if they go through one direction, go branch, originally they go to the true branch, but after their force execution, they go to the fourth branch. And go to the fourth branch, they will modify they can modify a set of variables or memories in the fourth branch, and then all the follow-up logic will be changed.
Yes. So so this is the part that is not super clear, because they basically just use an algorithm from another paper called uPensive, and there is like a feedback step. So they run through this. So for every change, then they will try to run the algorithm, and if the output is still a pass, then sorry, does that make sense? So
Yeah, I think we're stuck here. So tell me honestly, so how much you grasp this paper?
I think everything except how the modify part is done is clear to me, because
Okay.
the modify part, they basically just threw it to another paper.
Okay, let's keep going on.
Yeah, okay. So in the compare and modify step, right, so we also want to compare the traces a bit more carefully, because there are some loops that do not match up when we compare the static and the dynamic slice. So this is one example. So in the static slice, you can see that the whole function g is included in the static slice. But for the dynamic part, right, whether g1 executes or not does not affect whether this function fails. Okay, so in the dynamic slice of f1, we don't have this this whole chunk here. Whereas when we compare it with the static slice of this unit test, we will have it. And if we compare it like just step by step, right, then it will just report that, okay, the inflection point is here, when actually it will match up to execution further down. And the real part where it differs, the inflection point is like up here. So
Wait, so here, I'm gonna ask the questions. So why F1?
Why F1?
So giving the same program, this program actually take different input so that they can have different, it has different traces, right? Okay. Okay, keep going on.
Okay, so right, so basically the improvements that they made is to capture the scope of the loop. So so during the loop, right, if it uses the index as one of the data, then it will be counted. So sorry, so if it uses the data, then it is tagged together with the execution. Yeah, so in this case, right, because this line 7 depends on what is given in line 4, line 8. But okay.
So let me reference your point. Your point is that getting to execution trace, if we just consider the trace is just a token sequence, we will make a mistake, because the step, despite it looks like a token, despite a trace looks like a sequence, despite a token in sequence looks like a step in the trace, but the relation between steps is more complicated, because sometimes the step is happens within a control scope, or it's going to happen within a loop. And based on those structures, we cannot just apply traditional trace comparison algorithms. We should further analyze the program structure and to see whether a step depends on some other steps, or whether it's executed within a loop. And the loop is a very important feature to align to trace execution, right? This is the point.
Yeah, it's also mainly because of how like these two traces are not really comparable, right? Because one is dynamic and the other one is static. So that's where the difference.
Which way is dynamic?
So the one with the bar is always dynamic.
Okay, so one without bar is static.
Yeah, the one without bar is static.
How could it be static? This is execution trace, right?
Yeah, it's an execution trace, but we only.
And if it is execution trace, how could it be static?
Because we are only logging the areas that we picked out in the static slicing part. So,
yes.
Yeah. So static slice, and this one is dynamic slice. That's why.
No,
usually...
the point that if we apply dynamic slicings, there is supposed to be no trace. right? How could that be trace? Because if we apply dynamic slicing, sometimes we even cannot figure out the order. So I assume that both SFR and SU are execution trace. Am I right?
Yes, yes.
So
Yes.
if they are all execution trace, how can the static slicing play a role here? Because if this is just a trace, there's the only option left is a dynamic slicing.
Let's see, right?
Think about it.
Because-
So let me raise another example here. Focusing on their if conditions that x equals 2. And here is x equals 1. And here we're starting with x. Okay. So if we apply static slicings, both x equals 2 and equals 1 will be under the result, will be our result, right?
Mm.
But here, this is if condition. If condition means that when we run an execution, and this if condition will be either executed or not, but cannot be both, right? So suppose let me mark the line number here. The execution can either be 1, 2, 4 or 1, 2, 3, 4, right? So anyway, once we have a trace, we will have such a sequence. Once suppose that the execution trace is 1, 2, 4, it means that 3 will not be executed. So definitely 4 will definitely slice to 1, right? If we apply data slicing. And if the trace is 1, 2, 3, 4, so the slicing must be 4, must be sliced back to 3, right? So there's no other choice for us to do. So if there's a trace execution, there's no static slicing can play no role there.
Because what they did was using the slicing, right? They
I
marked out.
understand they're using the static slicing to decide which part of code should they record. But once
Yeah.
the code has been recorded, they can only apply dynamic slicing. Am I right?
Yes, 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 yes. So actually, where's the confusion? Because for this one is execution trace on the static slice, and this one is execution trace on the dynamic slice.
So here, the static slicing is applied on the static code. Dynamic slicing is applied on the dynamic execution, right? So
Okay.
I feel a bit confused about your description. And one trace is from static slicing and one trace is from dynamic slicing. So I feel a bit confused on your such description.
But do you agree that for static slice, you can also do execution trace?
No, static slicing, they basically are using different technique to do the slicings. So whatever, so giving your SFR and SU, SU is both one's execution, and SFR and SU are derived based on different input. Am I correct?
Yes, different input, yes.
Okay, so basically they are for your figure 6, they actually, so they are derived from the same technique. So why we need to distinguish static or dynamic slicing here? There's no need for us to distinguish them, right? So there's just they apply the same technique to derive the same result, but the only difference is that they apply a different trace. The input is different, right? For the first trace, the input is 1, and for the second one, the input is 2. So based on different input, they derive different trace. And based on the trace, they just build the date slicing and the control slicing, but all the slicing are dynamic. Because all the
Okay. Yeah, I think for your definition of dynamic slice, yeah, it will
Dynamic
work
slicing
like
is 4-step. Dynamic slicing is just 4-step. And the static slicing is for a static code. So for example, the static slicing is more complete, but dynamic slicing is more sound. So that is a trade-off, just what I mentioned. Suppose we have a trace of 1 to 4. The dynamic slicings will definitely just accurately tell us that given this execution, the reason the x the value of x, for example, is 1 is simply because the line 1 on line 1 x is assigned to be 1, right?
Yeah.
Okay, keep going on. So now we have traces here. So let's keep this. Let's move on. Assuming that we have different inputs, it derives different execution traces. And what's next?
Right. So we also attach the context to these steps, and then we are only matching when the context match. Right. So the exception to this is that in the case of mapping loops, so for map loops, they define it as those loops that do not depend on the index data, right? So for those, they will keep in, and then they will still compare like more strictly. Okay, so with that said, and then so for their static and dynamic slicing, it's possible that after dynamic slicing, you are removing some of the more important steps that helps you find out the root cause. So in this case, if we do a dynamic slice on SF, right, so this is, right, remember what I said about the number needed, right? So it didn't decrement, so this thing will not be included in the dynamic slice, and therefore line 22 will also not be. But for the passing test case, it decrements, right? So now it's included. And then now the only difference, the first inflection point between the dynamic slice of SF and SU will be the symptom itself. And so what the algorithm does is that they will switch over. So they will dynamic slice SU and then compare it against the static slice SF. So they'll just keep comparing until all the prefix match up.
Let me rephrase your point. Your point is that if we want to find the root cause, the bug can either out of we executed something we should not execute, or we mis-executed something it should execute, which should be executed, right? So here the recapturing operations is that we want to check whether we missed, for giving the execution, whether there are some steps we mis-executed or whether there's some code we mis-executed, right? So based on their idea, they're going to do some static slicing to include line, for example, to include line 24 back, so that we know, and if this line is executed in the correct trace, and we will put them into, we'll take them into considerations and keep going up. Is that your point?
Yes, yes.
And how they including, and also I feel really confused. One point is that maybe this is just for a discussion. The correct trace is derived with the input function of 1, and the buggy trace is derived from another input, and a different input, and how reasonable for us to reference a trace with different input. For example, suppose we have a trace like here. Would I write a program control flow graph? Suppose the control graph is here, right? And if the input is, let me use one color. when input is 1, we go this trace, we go this, we traverse the CFG such as this direction. If the input is 2, we traverse the CFG in this direction, right? So they can be, and suppose this is pass, and this is fail, right? And those two traces looks very different now. And how reasonable should we use these trace, the green trace, to infer which code is wrong on the purpose trace? You get what I mean?
Yeah. Yeah.
So no worry. So because you are just an undergraduate student, it is not easy for you to fully. I think all the undergraduate students, you may not so easy to go to digest all the contents of paper, but sometimes when we read the paper, we should think. We should apply critical thinking. So when the paper is supposed to be very long, and a lot of words are actually supporting their opinions, and we should think on the other side to think about whether their assumption or whether their scientific assumptions is reasonable enough.
Okay. Maybe I want to add on a little bit. So there can be the case where, let's say that this green trace is my passing test, and then let's say that this is the branching statement, right? And maybe the flow goes back here, right? And if I follow this, let me try to find a color. Then if I go this way, then it's still a pass, right? Yeah, so for the modify part, what it's trying to do is basically to find this kind of traces, and it will just modify the test case such that now it follows the blue path. And so now we have a longer common prefix.
I understand. Even if we have a longer common prefix, for example, in the worst case, suppose there's a program, there's no if conditions, and all is a sequential, right? So you can think about the complexity of trace comparison, just like seeing there's for and if loop, for condition, if condition and a loop condition, right? If there's no loop conditions, we can trace comparison is exactly like the sequence comparison, right? The sequence alignment. So let's take a thought experiment. Suppose the programs there's no in the control flow graph. So there's no conditions. There's no condition statement. So basically it is just a list of instruction, right? The program looks like its instructions. Giving and here is there's all the variable propagation, right? Suppose here is we define x equals 1, x is equal to the input, right? A equals x creates the x plus 1, b equals x plus 5, and c equals a plus b is actually as follows, and we output z. Okay, so suppose we have these programs. So in this case, whatever input is, and it will have exactly the same trace. And on each trace steps, the variable will totally different, right? So suppose given x equals 1 equals 2, they'll be totally different. Suppose there's bug like maybe d equals c squared, right? And if it is written by d equals c plus c, in this case, so this is supposed to be a bug, right? And how can we know this? We have no idea, right? So for the passing case, suppose c equals 2, then this will be passed because c squared just equals c plus c or 2c. And then we have another bug. Then we have another execution. or we change the input, and these steps, we will just have a failure. And how we can leverage the idea, leverage their approach. Right. So there's a big concern for me. So there's big concern. You say using different input, and the program is just the same, and how reliable is that reference? So that is my big concern. Even if they share the same prefix, and this is extreme, right? It means that suppose there's a sequential program, suppose there's a sequential programs, they will have exactly the same execution trace. The only difference is that the variable, the read variables will have different value, and that's all. And if we trace it back, and then we can trace back to the reason is that the input is different.
Yeah, I think that's one of the main limitations of this.
I think that is a very fundamental. So it makes the debug, because I think about these problems a lot. So usually if we and your project is called automated debugging. And if we want to automatically debug something, we must have something, we must know the current reference. In this world, we must know something. If we want to say you're wrong, if we want to say someone is wrong, we must have some rules or reference about what is correct. Yeah, for example, we should respect the elders. And so some misbehaviors were considered incorrect because we have a mind value there. So the same idea should apply on debugging a program. If we know a program is buggy, we must have its correct specification in our mind. So if we want to automate this process, the idea is that we must have a reliable reference. And here, they provide input. They just provide different input. They align with different input. I just doubt they have rationale, because from my point of view, it may not be that a reliable reference.
Yeah, they avoided this whole class of problems because they only care about when the execution diverges. So actually, like throughout the whole paper, right, they didn't talk about the values of the variables at all. They don't care. They only care about what steps are executed.
Yeah, another version is like this. So, for example, so the question I repetitively ask you is that whether they share the same input. If they do not share the same input, from my point of view, the comparison, the reference may not that reliable. So now let me take one step. Since they are locked into a distributed system, or distributed system have this concurrent nature, right? So that means each time we execute the program, and the step may not be exactly the same, right? For example, if we have the experience of Java concurrency or Python multi-threaded Python program, we may know that each time we run a versions, then the result will be a little bit different. And even if we feed the same input into the program, the reason is that the operation system may schedule the process and the thread differently each time we run it. So here comes to be a question is that, suppose given a concurrent program or distributed systems, given the same input, for example, we run it for a few times, it have the result of 2, and it suddenly given the same input, it provides a different result. Then we are able to compare the 2 execution trace, because the execution trace, because that execution trace with correct output can now fully used to be infer where the buggy trace, why the buggy trace will happen based on the Java scheduling. So maybe we synchronize some code block, or we do not consider some maybe the deadlock problems, or data rate problem, etc. Have I made myself understood?
Yeah.
Okay, let's keep continuous. Maybe we can finish this version. Maybe we can finish this version within 5 to 10 minutes. Then we're gonna see whether we have. Then we let me have a look whether we still have the time for the next for your new paper presentation.
Right.
If needed, we can reschedule to next week. Your presentation to next week. Okay, let's keep going on.
Yeah, that's basically all I want to add on really. So there's this concept of this divergence point, whether it's failure or oblivious. So if such a route can be taken while still ensuring a pass, then we will just modify this unit test to unit test prime, and then now we use this as a longer common prefix. Yeah, then that's all. Other than that, I added in some figures for the experimental results.
Yeah, so here they look into, and also I'm curious about how they constructed the trace execution on the distributed system, right? They are looking to the distribution system problems. So how they constructed the trace, because giving a distributed system, the node, there's communication between the nodes, right? And so the trace itself cannot be a script sequence anymore. I think we once discussed this problem. Suppose it is concurrent system, and suppose this node is going to fork a thread, and both now we have a thread running in parallel, and then interleave. Sometimes they will also change the data, right? They will modify some steps on one trace on the thread will write to variables, and another thread will read that variables. In this case, these two threads will communicate with each other, and also some threads maybe enter a synchronized block. In this case, other thread have to be blocked on the other a block on the other block and on the critical sections, the other threads will be fully blocked. So that trace is not a sequential structure anymore. Does this paper consider those kind of the situation?
I think for the communication, they use some annotation library for the different messages between the processors. And for the interleaving execution, I think like most of it gets solved when because for the buggy there's only one execution, so it's just a
So this is
just
very
compare in
simple.
time.
So,
Yeah.
okay, so maybe we can record those papers. Maybe later, if we want to extend our approach on those distributed systems, and I will have a look. Okay, so maybe that's all what you have, right? So that's what I have. So will you please show us your prepared slides for another? Yeah, how many slides have you prepared?
Oh, this one 29.
29, right? So let me quickly go through your slides, and then we decide. Let me think about it. Probably we need to postpone your presentations to next week because it is already 4:30. Let me quickly go through your slide.
Okay, sure.
Start from the first slide, and the parallel. Okay, keep going on.
Okay, so
let me quickly go through it. Okay, let's go through it.
okay, so the background, and then basically yeah, so compare against existing measures, and then basically there are like two parallel algorithms that they contributed, and I have to talk about some background information about how they do the pointer analysis, and then this is what happens to the graph when you do additions and deletions. and then there is also a static happens
Okay,
before.
okay, so that's very great. So, Yuchen, I suggested that you go through the slides again, and especially for the equivalent part, you can provide an animation. I think, oh, by the way, I'm going to say that Yuchen's research or research presentation is quite relevant to Darren, Xianglin, and Yijie. So all of you, and all of you are the research will be relevant to the proof analysis. So sometimes when we will have recorded trace, we will go through how the control flow and data flow are propagate each other. For example, for EGS security project, we would like to analyze how we can summarize the trace representations of the code semantics. And also, but the Xianglin is not here. The Xianglin is going to do some trace alignment later. Darren's, it's good for you to fully understand what is static analysis, what is dynamic analysis, and how to apply control flow and data flow there. And then we can proceed with more details. Okay, Yuchen, maybe we can postpone your presentation later, but you can first share your slides in the group. I can have a look at you and provide a few comments to see whether my comments can further improve your presentation.
Sure.
Okay, so maybe we can call it a day for these meetings. Thanks everyone for attending. And later I will send you emails about more detailed tasks. And for EGS, I will also, for EGS and Docus, I think your task hasn't been very clear now. I understand you may have some internship in the summer, but I suggest that you can at least spend a few hours a week on the FYP program so that you can get yourself warm up. Anyway, you will have an advantage if you start earlier. For example, in your previous batch or the seniors, we have 2 FYP students have publications in top-tier conference, and they all start very early. Because even for a PhD student in SOC, it takes time to get established research work published. Hopefully, so that I think for undergrad students, we will have a much. It is great. It is a big move to doing something for what undergrad student can do. Okay, so maybe that is just my summarization. And thanks everyone for attending. Is there any questions for today's meetings or your if you can feel free to ask any questions.
When can we have
Maybe Xianglin can stay.
okay.
Okay,